So here's a question to start us off. Is time travel possible? Could we ever rewind the clock? The concept of time is deeply woven into our everyday lives, but it remains one of the most mysterious notions in physics. Intriguingly, the idea of reversing time doesn't just exist in sci-fi stories. It has also perplexed the greatest scientific minds. So, in this video, we'll embark on an intellectual voyage, drawing upon theories of relativity, quantum mechanics, and a dab of theoretical physics. In sci-fi, time travel usually involves hopping into a fancy machine or portal and then emerging in the past or future. Simple, right? However, in the realm of real science, things are a bit more complex. The answer lies in the laws of physics, specifically the second law of thermodynamics and the concept of entropy. Entropy is a measure of disorder. According to the second law of thermodynamics, the total entropy or disorder in a closed system, like our universe, always increases over time. This principle is one of the root causes of the arrow of time, pointing firmly in the forward direction. Now, let's bring in a touch of quantum mechanics. You've likely heard of the famous Schrödinger's cat thought experiment, haven't you? It talks about a paradox where a cat in a box is simultaneously dead and alive until someone observes it. Only then does it snap into one state or the other. In 2019, scientists from the Argonne National Laboratory reported evidence of a time-reversed version of this phenomenon, something they call a quantum time crystal. Under the right conditions, particles in this time crystal evolve backward and forward in time, giving us hints of time reversal. But remember, we are still only at the quantum level here. Could such time reversal ever be possible for us humans or our macroscopic world? If we define time reversal as retracing our path back to the past, then it seems utterly impossible, doesn't it? That's because of everything we talked about already. The increasing disorder in the universe and the irreversible nature of many physical processes. But what about our perception? Is it possible to perceive time moving backward? In a fascinating study, scientists at the University of Cambridge found that honeybees can learn to associate a reward with a picture shown earlier. In a sense, they remember the future. While it's still highly speculative to interpret these findings as examples of biological time travel, it's surely intriguing, isn't it? Certainly, this type of cause-effect relationship is outside of our everyday experience. But then, so are many other ideas in quantum mechanics. Some interpretations of quantum mechanics actually entertain the possibility of retrocausality. But, and this is crucial, these theories still aren't mainstream consensus. Remember Einstein's relativity? It tells us another startling thing. Time is not absolute. It can stretch or shrink depending on speed and gravity. In other words, time can slow down for you if you travel super fast or near a massive object. This is known as time dilation, and it's been proven with precise experiments. But here's the catch. Special relativity allows for time dilation but not reversal. To travel back in time, we'd need something more. In theory, so-called wormholes could tunnel through the fabric of space-time, creating shortcuts between different points in space or even different moments in time. But we should note science hasn't yet discovered any real wormholes. The concept still largely exists only on chalkboards and in mathematics. Moreover, traversing a wormhole without getting crushed by immense gravitational forces would be another formidable challenge. So while wormholes are possible in theory, using them for any practical purpose, let alone time travel, remains in the realm of extreme speculation. So, as it stands now, if we define time reversal as physically going back to a point in our past and changing the course of events, then the odds are stacked heavily against it. But as we've seen, at the microscopic quantum level, there are hints of phenomena that look a bit like time reversal, even though they're not quite the same thing. Again, it's important to remember that these are not the same as physically traveling back in time. Still, they provide fascinating insights into the strange nature of quantum mechanics. Some cognitive scientists think so. Experiments with virtual reality have shown that our perceptions of time can be manipulated. For instance, altering visual cues can make people perceive a shorter duration as longer or vice versa. In essence, While time reversal in the form of physical time travel remains a far-off dream, there are intriguing phenomena both in quantum physics and neuroscience that challenge our standard notions of time. But for now, time, it seems, will continue its relentless march forward, at least for us humans. As we ponder the secrets of time, we should remember that it is this forward movement of time that gives us the ability to create, dream, and grow. Perhaps it's about learning to live in each moment, understanding our past, and bravely sailing into the future. Until next time, keep exploring and remember, time waits for no one.